Hey guys, this is the High School Scientist, and in this video we will be solving multiple choice questions from the first chapter of 11th grade textbooks. Before we start, let's make it a bit harder by not using the multiple choices that we have in our textbooks, but rather by finding the answers ourselves. Find the unit of this expression. Now h is the Planck's constant, but what exactly does that mean? Well, it's the smallest possible value for energy that can exist. That is, the value of energy cannot be decreased below the Planck's constant. It's the most fundamental and possibly the tiniest thing that can exist in our universe. Its value is 6.626 times 10 to the power negative 34. And you can also visualize it as this number. Yeah, that's how small it is. So the equation of the Planck's constant is energy by frequency. The unit of energy is joules and that of frequency is seconds. Therefore, the unit of Planck's constant is joules per second. And since c is the speed of light, its unit is meters per second. Next up is the gravitational constant. Now it's much easier to memorize its values and spit out the answer, but let's just take a step back and try to understand what it really means. We find that the attraction exerted by the Earth on an object is 9.807 meters per second, which is the rate at which a body falls towards the Earth. This value thus decreases over distance, but we won't be taking that into account in this scenario. The real question is why this exact value? Why can't it be 15 meters per second or 30 meters per second for the exact same mass and size? It's because of this constant value. It's also called as the big G. Its value decides the amount of gravity an object can have, and this also decides the fate of the universe. If the big G was any bigger, the universe would collapse under its own gravity. And if it were any smaller, planets and stars would never form. So this particular value is really important. So on to the question. The expression of the big G is force times distance square divided by the square of mass, and its units are Newton meter square divided by kilogram square. Now we have all the units, and just by equating them we get joules multiplied by kilogram square divided by Newton meter. We can simplify it further by replacing joules with Newton meter, and hence we get kilogram square. Moving on to the next question. If there is an error of 2% while measuring the radius of a sphere, then find the error which would occur while measuring the volume of that sphere. The formula for volume of a sphere is 4 by 3 pi r cube. If the radius can be deviated by 2%, then the total error in the volume of the sphere depends upon the number of times we use the radius in the equation. In this case, we use the radius 3 times, and hence the total error is 6%. Moving on to the next question. If the length and time period of an oscillating pendulum have errors of 1% and 3% respectively, then what will be the error in the measurement of acceleration due to gravity? Okay, so the formula to find the acceleration due to gravity is 4 pi square multiplied by length and divided by the square of time. And this formula could be used to find the total measurement error. But let's find an intuitive way of solving this problem. Now it doesn't matter where the error is. It can be in the numerator or the denominator. All that matters is how many times does the error occurs in the original formula. So we can see that there is an error of 1% while measuring the length of the pendulum and an error of 3% while measuring the time taken for one oscillation. So when we add all the errors together, we get the total error, which is 7%. Moving on to the next question. If the length of a body is measured as 3.51 meters and the accuracy while measuring is 0.01 millimeters, then find the percentage error in this measurement. Using the same formula, we take A as the measured length and a slight change in A as the accuracy or the amount of deviation by the instrument. So equating the expression with these values gives us the percentage error in the measurement, which is 0.28%. Now let's move on to the final question, and this question happens to be the most complicated question in the entire textbook. If the value of pi is 3.14, then find the value of pi square. I can't believe that this question is present in the textbook. Before we actually get into it, let's learn what pi actually is. If you divide the diameter of any circle with its circumference, you get a value which is 3.14, which shows that the ratio of the circumference to its diameter is 3.14. It could also mean that the diameter of a circle is always 3.14 times smaller than its circumference. Now that you know what pi means, you can solve the question by yourselves. And I will be solving the other questions in my upcoming videos. So until then, just spread the word about this channel. This is the High School Scientist signing off.